Okay, it's time to look at some work examples. So right here we have the first very question on the board. 3.18 gram of copper 2 oxide was found to contain 2.54 gram of copper and 0.64 gram of oxygen. What is the empirical formula of the compound? Now we've been given the all the information we need about this very compound, and so we're asked to write the empirical formula of this very compound. So as you can see, 3.18 gram of copper 2 oxide contains what? What does it contain? It contains 2.54 gram of copper. Copper I see you, copper. And what else does it contain? 0.64 gram of oxygen. So we are asked to write the chemical formula for this. Now don't forget something. By the time you add those two together, 2.54 gram and 0.64 gram, when you add them together, you will get 3.18 gram of copper 2 oxide. So now how do we write the chemical formula? Don't forget the two things that we need to know. The first is what we'll call the mass or the percentage composition, and after that the mole concept. So you're going to be using the two of them. For the mole, it's down to the mass of the molar mass. Or sometimes if you don't want to use the mass, you can use the percentage of each of the mass. Like 2.54 of copper, we have more copper in this than oxygen. You have 2.54 gram of copper in that is out of 3.18 gram of copper 2 oxide, and we have 0.64. So we have more copper than oxygen in this very chemical compound. So now what do we do? The first thing we're going to draw our table. I'm going to draw our table. This copper here, the copper section, and this is the oxygen section. So for the copper, we have 2.54 gram of copper, and while here we have 0.64 gram of oxygen. Now what we're going to do, we're going to get our mole, the mole for each of them. So what's formula for mole? Mole is mass over molar mass. So mass over molar mass, or you can call it, it depends. You could call it mass over atomic mass. It depends if you just one atom of that very compound we're talking about, like let's say just an atom of copper. So what's the atomic mass of copper? Is 64. So 2.64, 2.5, I beg your pardon, over 64. While oxygen is 0.64 over 16. Now I'm going to show you also that we could use our percentage. We could decide to use percentage. Once we're done with this, we try it the other way around. So 2.54 over 64, there's a mole, the mole of this, and also there's a mole of this. So 2.54 over 64, we're going to be using our calculator to get that done. Let's see what that would give to us. 2.54 divided by 64. What do we have? We have 0.039. So we can call that